Hi there, my name is Daniel Gallo. I'm a solutions engineer on the TeamCity team at JetBrains, and I'm here to talk to you about 15 practical ways to optimize your cloud CI and CD costs. So, first of all, why is your cloud CI and CD burning money? Uh, Although cloud-based CI/CD tools do offer increased scalability and convenience, so you can gradually increase your usage over time without increasing your own data center size. The costs associated with that cloud-based solution can quickly escalate with your increased usage. And this can be due to a number of reasons. For example, there could be unused build agents or idle time while the agent isn't doing anything. You might have inefficient pipelines where some of your dependencies might not be reused where they could be. There might also be redundant triggers, and you could be triggering too many builds or too often, or perhaps not combining multiple commits under a single build. There could also be poor resource planning, so you could be committing to too many resources upfront when you don't necessarily need all of those resources. So there are a number of areas through which DevOps and engineering teams need to keep tabs on in order to manage their costs and stay within budget. So in this session today, I'll be tying some of the examples I cover into the context of JetBrains' own CI/CD solution, TeamCity. And while not every technique I cover today applies to all of the CI solutions on the market, they do highlight key opportunities through which you can hopefully improve the efficiency and reduce your spend. So let's jump right in. So point number one here is version control username mapping. In a lot of cloud-based solutions, the pricing for the solution is based on the number of developers you have. So if you have developers that are making commits under different version control usernames, those might be counted as multiple developers, even though they're the same single developer. So if there's a way for you to avoid duplicate users by combining all of the different combination of version control usernames under a single developer account, this ensures you only pay for the actual developers on your team. So in JetBrains' own solution, TeamCity, we help with this by allowing users to specify up to 3 version control usernames for each developer. Point number 2 is monitoring the build agent performance. And it can be quite tempting to run all of your builds on a high spec agent just to get the maximum throughput from that particular build. But you might not necessarily be leveraging the full capabilities or the full resources of that agent. So if you have a way to capture performance metrics while the build is running, for example, CPU, RAM usage, this can help you to right size the agents and help assign your jobs to appropriately sized agents without overspending. And TeamCity helps with this by providing a nice feature called Performance Monitor. And this helps to capture the resource consumption of the agent while the build is running. And this can help you to see whether the CPU is being maxed out or if it's just really low usage. If it's really low usage and it's running on a large instance, you could then consider running it on a smaller instance to drastically reduce the cost. Point number 3 is analyzing resource intensive jobs. So, where possible, try and identify your high cost projects and jobs and see which ones could be perhaps cut down or just run less frequently. And also consider combining multiple commits under a single build rather than separate jobs, especially if they are long running or they run on a high cost agent. And TeamCity helps with this by providing what we call a matrix view, and this helps you to analyze all of your projects as well as the overall spend or the overall build time across all of those agents. So, like small, medium, large agents. And if there are large agents being used, you can then go down and see whether those are needed or not. Point number 4 is terminating agents during long external calls. Now, this isn't necessarily possible in every cloud CI solution, but if you are calling an external service that runs for a long time from your job, traditionally your agent would just be sat there waiting for that service to complete or call back. So, if possible, try and use an agentless step to pause the agent usage during those long wait periods. This will enable the external process to continue running, but your agent doesn't have to be running. It can be terminated, and then that service could call back to your CI, and then when it's finished, and then tell it once that's done. In TeamCity, we support the concept of agentless build steps. So this is where you could call an external service and then essentially detach and terminate the agent after calling it. And that way you're not spending build minutes waiting for that external service to finish running. Point number 5 is setting quiet periods for your VCS triggers or your version control triggers. So when a developer makes a commit, typically you run a new build in your CI. But you might want to consider avoiding triggering a build on every small commit and perhaps combine them together under a single build. Because this can lead to excessive consumption of resources and therefore increased costs. So if you do have a way to batch multiple commits together under a single build, that can really reduce your resource consumption and costs, especially if it's on a high spec agent and it's a long running build. So some CI solutions support the concept of a quiet period, and this is a time frame for which to wait between the last commit and triggering the build. So if there are no commits over a certain time period, only then will the CI consider running a build. In TeamCity specifically, we enable you to define what we call a quiet period on a version control trigger, and this allows you to do the exact thing. So you can only run jobs if there are no new commits within a certain defined time period. Point number 6 is making use of checkout rules. So you could be making changes to a file and then triggering a job, but if that job doesn't necessarily depend on that file or use that file for that job, there's no reason to run that job. It could be reused if there's one from a previous execution. So where possible, try and trigger jobs only for the relevant file changes, and this will help prevent unnecessary builds and reduce your build time accordingly. In TeamCity specifically, we provide an option to define checkout rules, and this limits the folders that are checked out onto the build agent, which reduces the checkout time and also helps ignore changes to those excluded folders. Number 7 is all around time limits for your jobs. So if you want to try and prevent hung jobs from wasting your valuable build minutes, you could consider setting failure conditions for catching any really long or abnormally long build runs. And in TeamCity, this enables you to define a maximum time limit for the job. So if you know that your build always takes just like 3 or 4 minutes to run, you could set a maximum time limit to catch any hung builds. You can also fail builds on other metrics, and you could define the maximum time limit globally if needed. Point number 8 is using self-hosted agents. So if you're making use of any bespoke tools or any tools that require licensing or maybe large dependencies you need within your infrastructure or within your private cloud, you could make use of self-hosted agents. So you can reduce your costs for these jobs by running them on self-hosted agents instead of cloud agents. And many CI tools allow combining cloud and self-hosted agents together, so you shouldn't have to switch from one to the other. You can use both. And in TeamCity Cloud, we do allow you to connect an unlimited number of self-hosted agents, and you will define the maximum concurrency of builds running across all those agents, so you can mix and match them. You can also run builds on cloud agents if needed. Point number 9 is leveraging Docker for dependencies. So some of your dependencies might not be pre-installed on the cloud agents. Maybe there's a specific version of Node.js that you require. If it's not pre-installed, you might either have to install that as part of your job or find another way to run it. And one way to do that is making use of a Docker container. So by specifying the build step to run inside of a particular Docker container with the build tool installed, this will allow you to avoid manually setting it up on the agent as part of your build process. This can also help improve the consistency and speed of builds because you're not having to manually install it as part of your command line steps, and also improve consistency because you can define the exact version of the container you want to use. And in TeamCity, we have built-in support for running build steps inside of containers. These could be on Docker Hub or your own custom registry. So when you specify a particular image and version, it will be fetched from that container registry, and the step will run in the context of that container. So it's a great way to run a build inside of a container. Point number 10 is reusing build results. So where possible, always try and break your pipelines into separate jobs. It can be quite tempting to lump together your build, your test, your deploy steps into a single job. But that doesn't help with things like reusability, because if your deployment process fails, you then have to run the entire job from the start because it's all under a single job rather than separate. So by separating things out, this allows you to reuse successful results instead of rerunning everything from scratch. And this goes back to an earlier point because you could combine this with checkout rules to help ensure only the exact jobs that need executing are executed. So if you change a file that doesn't affect some of the jobs, it won't trigger those jobs from executing. And in TeamCity, we have the concept of build chains, and this helps you to automatically reuse your dependencies if there are no new changes. So if there's a build that doesn't have any changes that impact in it, it will always reuse that dependency, therefore cutting down the time it takes to run the pipeline. Point number 11 is passing dependencies as artifacts between jobs. So if you have different jobs in the pipeline, they could all be using the same dependencies. For example, they could all be downloading NPM packages or some other packages from an external server. Rather than downloading all of those dependencies over the internet each time, you could store those dependencies as caches or artifact caches and share them across your build pipeline. This helps avoid the redundant downloads and installs and should hopefully increase the performance of your pipeline. And in TeamCity Cloud, we do provide built-in artifact storage. So one of the things you could do is use our built-in build cache feature to cache certain dependencies rather than downloading them again or rebuilding them for every single build. And you can also store just standard build artifacts in that storage. Number 12 is prepaying for build agents. So if you are always running builds on per minute agents, where you pay for every single minute a build is running, some cloud CI solutions might allow you to prepay for a certain number of agents or unlimited builds on different types of agents, and that can reduce the equivalent per minute cost because you're just paying a flat monthly rate. And in TeamCity Cloud, we do provide both per minute as well as prepaid agents or prepaid cloud agents. So if you do make heavy use of a particular type of agent, like a Linux small agent, you can consider prepaying for those or a certain number of those types of agents, which could be more cost effective than using the per minute option. Point number 13 is considering right-sizing your subscription. And what we mean by this is keeping a close eye on the resources that you have allocated to you each month and see whether they are being used. So, if there's a way to track your resource consumption through the month, this should help you see whether you are over allocated or under allocated, and you can then size your subscription appropriately. So essentially just matching your cloud subscription to your actual usage or as close to that as possible. And then some CEI or cloud CI solutions allow you to use credits to add additional resources as needed. And in TeamCity Cloud, we do have the concept of build credits, and these credits can be redeemed for all of the resources such as build time, additional developer seats, self-hosted agents, and extra storage. And then point number 14 is reviewing your auto-renewed resources. So if there are any resources that you've committed to in a particular month, maybe there's a busy period where you've added more resources, you might need to make sure that you cancel those unused recurring resources just to avoid any additional month-to-month charges. Yeah, so essentially adjusting this monthly based on your project needs. And in TeamCity Cloud, resources, as I mentioned, are redeemed through credits, and those do auto-renew each month. But we do provide an admin UI where you can quickly modify resources, so you can cut down any resources for the following month if they're no longer needed. And then last one on the list is number 15, so saving admin time with templates. So cost savings can also be achieved through time savings. And in the example here, we mentioned things like pipeline templates. So by reusing build pipeline logic, you can cut down the amount of time it takes to administer or set up your build pipeline and reuse that logic. So it reduces the overhead from the repetitive configuration. And you can also consider making use of other features within the Cloud CI to have additional time savings. For example, if you make use of user groups to manage permissions rather than granting user access at the individual user level, you get a time saving from that side of things. And templates could be a number of different things. They could be configuration-based templates in code like YAML. And in TeamCity, we do provide various time-saving capabilities, such as auto-detection of build steps. We have templates for build pipelines, which could be Kotlin DSL-based. They could be templates within the UI, because we do allow full UI configuration of your pipeline, or an external shared library where you have some common methods or classes that you want to reuse in your Kotlin DSL-based projects. So some final thoughts. There are many ways to optimize your cloud CI/CD costs, as we've covered in the session today, regardless of your chosen vendor. So hopefully you can choose one action point from today's session to implement this week, and then keep iterating on that. And cutting costs isn't just about cutting corners, it's about building smarter. So through small tweaks across your pipeline based on the recommendations we've covered today, this can hopefully lead to significant time and cost savings. And essentially a leaner CI/CD means greater efficiency and less wasted spend on your part. And if you're interested in trying TeamCity, you can go to jetbrains.com/TeamCity and try it today. So thanks for your time, thanks for watching, and I hope you've enjoyed the session. Goodbye.